Hey everybody, welcome to the Weather Breakdown. Today is January 6th, the third video of the year, and in our last two videos, we've talked about the onslaught of a serial cyclogenesis regime that is going to push the cold away to the eastern part of Europe. We're going to see if that statement still holds true. Number two, we're going to also look at two systems that we have already talked about. Number one is a frontal snow zone that is going to start to impact central Western Europe tomorrow, which is already impacting the UK today. We are also going to look at a storm system that is going to start this serial cyclogenesis regime, and that storm system might bring a lot of wind, a lot of rain, and a lot of snow. And depending on the track, it will lead to wildly different outcomes. Okay, so today we are going to look again, as in our previous videos, how the weather looks like today in our observation platform, and then move over to the weather charts. Let's dive straight in and see what we can expect. Okay. See you there. So, guys, what can we see in our weather observations? As we've already been discussing, we have a high pressure center here, which was originally more to the north. And we've already been discussing that this will migrate towards the south. As you can see, this high pressure center is already in its location where we've predicted it would be. We have around that, we have a few other systems. We have a low pressure center here with its frontal boundary moving like this, connecting to another low pressure center here. And it's this low pressure center with its accompanying occlusion that is going to impact parts of France, Benelux areas, Denmark, and Germany, which is now already impacting the UK, as you can see. We still have this regime of cold air because there are low pressure centers here as well, leading to a northwesterly flow, leading to a frontal boundary here, bumping against the warmer air mass in this region. So what we will now see is that due to the orientation of the 500 millibar height lines, these are already oriented a little bit more zonal, and this will lead to a orientation of a zonal warm conveyor belt, which will move the storm depression towards the European mainland. Now, what I've done here for you guys is I have created a cross section, a vertical cross section over the three different fronts, and we can show you in the cross section how their slope or the slope of the fronts look like if you look at it from a three-dimensional perspective. So if we tilt the map right now, right, what you see here are lines of equal height. These are the white horizontal lines, okay? And the sloping lines are actually lines of equal potential temperature called isentropes, okay? Now, as this cross-section crosses all these fronts, you see that each of the fronts have different slopes in terms of their isentrope. If you look here, for example, along the cold front, you see this is a cold front, right? And along this cold front, you see tightly spaced isentropes. These tightly spaced isentropes is actually a visualization of the cold front, okay? So this cold front acts to move the air upward. If we zoom out a bit, you can see a grayscale fill of the relative humidity. So this front with its frontal slope here pushes this air upward, leading to a vertical extent in the cloud field. Also, if you look here, we have this warm front here, and if we go along the warm front, you can see the air rising upward because air, as it moves from left to right here, it follows more or less the isentropes here. So as it moves here, you can see it rising over the warm front, right? And while it rises over the warm front, it squeezes out all the moisture, leading to precipitation just ahead of the warm front here. And if we look further at this occlusion, we can see the characteristic drop in the isentropes and the characteristic climb here, signifying the frontal zone here. So we have here the cold front extending like this, we have the warm front like this, and then we have this V shape here along the frontal boundary of the occlusion. I thought it was a good idea to already show this to you guys and see how fronts actually behave. But we will delve a little bit more into that on Friday when we look at the cyclogenesis case that is about to unfold with a potential high wind field. But let's not waste any more time. Let's go straight to the weather charts and see what we can expect right now. Okay? See you there. Now, if we look at our weather charts, we see what we have been discussing. We have the high pressure area here as it migrated from there to there. We see here the spacing of the 500 millibar height lines moving more in a zonal direction. What will happen? You will see that this system that's just outside the domain here will start to be detached from its warm conveyor belt, as this warm conveyor belt, now oriented like this, will start to be oriented in a more zonal direction. What you can also see because of that is that if we move forward in time, you will see the serial cyclogenesis regime popping up with low number 1 here, low number 2 here, low number 3 in its wake, low number 4 in its wake, low number 5, low number 6, and so forth. Okay, the European model is saying more or less the same, but with a twist. So what the European model is doing, it's having the same thing. It's having this high pressure area here with the 500 millibar height lines, tightly spaced, oriented more zonal. The system here outside the domain will be detached from its warm conveyor belt, as its orientation will also move more zonal. That's completely in line with what the American model is saying. But if we move forward in time, we see also this low pressure area here. We're going to delve a little bit more into that one further. Right, but look forward to what's happening. We see the serial cyclogenesis regime with other lows here in its wake. But as time progresses, we see here that from the north, there's a high pressure area invading here to the south. And what this is doing, this manifests itself further and further and further. And while the serial cyclogenesis regime is going on, this high pressure area here, right, with all the lows coming here from the Atlantic, sets up a deformation zone here, deflecting all the lows towards the south. These two regimes here, these low pressure areas and these high pressure areas, funnel frigid air to the mainland and the western part of Europe. This is where the European model and the American model differ, and they differ quite a lot in that regard. And this has massive implications on our temperature as well. But we've already talked about this in the first video of the year, that when these lows start to linger here, that there would be frigid temperatures moving on their north flank towards the west, and this is what you can see here. Now, this has massive implications in our temperature, as you can see, because if we move to the temperature field and we circle back to the beginning and we let move, we see indeed as these low pressure areas here, especially this big one, starts to crash into Europe, it sets up a boundary like this, where the colder temperatures are more towards the east and the milder temperatures invading from the west due to the cyclone bashing the European mainland. And if we move forward in time, we will see what happens. If we move forward in time, you see this low here migrating toward the south with a high pressure area here. And as we move forward in time, there's another high pressure area working together with this one to create a bigger one. And this, as you can see here by the temperature field and the MSLP field, there's a deformation zone here with the collision point here and the axis of contraction like this and the axis of dilatation like this. This makes it so that the whole flow moving over the Atlantic is being deflected towards the south, leading to an engine here with a low pressure here, high pressure area here, funneling all that cold air towards the west. Okay, now if you look at the temperature field in the GFS, we don't see this happening. Why? Because we do not see this deformation zone. We do not see this high pressure area. These lows just keep bashing the European mainland, and the temperature or the cold temperatures keep getting pushed back towards the east, as you can see here. Oh, we're still in the European model. Sorry. If we take the American model, we see all these low pressure centers bashing the European mainland and the temperature fields, apart from freezing temperatures and in the evening and night and early morning, they are pushed back towards the east. Okay, but we will see how the difference between the European model and the American model play out. But let's first look at the snow zone, as we've already talked about first. Okay, so let's take a look at the precipitation type. We've already mentioned in our previous section of the video that we have the low pressure center here with its occlusion that is going to impact the European mainland, which is already impacting parts of Europe, especially the northern part, Scotland here. All right. Now, if we move forward in time, you will see that transpire as this low pressure center moves towards the south and southeast, and the European mainland having very cold temperatures, that this precipitation falls as snow. And if we move forward in time, look at the time here. The time at which this happens are peak morning rush hours. So we can expect a lot of traffic jams, both in the Benelux areas and France. If you move forward in time, you will see that area of snow starting to dilute a bit, and we then see the onslaught of this low pressure area here. The European model, it tells more or less the same story. So let's now delve a little bit into this low pressure area before we close off the video. Let's turn off our wind gusts here. If you move forward in time, you see this low pressure area forming, and it's still the exact same story. Both the GFS and the European model predict a drop of 30 millibars over 24 hours. 30 millibars over 24 hours. This is definitely a rapid cyclogenesis case, and definitely this will bring problems, either if it's wind, it's rain, it's snow, it will impact a wider area, right? While the GFS is saying that it moves in more or less in this direction, with the maximum wind field situated more or less in front of the French coast. It goes like this and it scours over the channel. If we follow the European model, the European model is predicting a slightly different course and slightly more north, and this means that the southern flank is directly situated over the channels, leading to a potential higher wind field and more impact along the French coast. If we zoom a little bit in, you will see here that these are wind speeds that are going to impact the coast, predicted around 110 to 120, 130, even peaks to 150 are not out of the question here. And if you can see here, this situation continues along the French coast, even the Belgium coast, and then it scours over the mainland and starts to dissolve, leading to, again, a pressure rise, leading to the demise of the system. So we will see how it transpires in the next coming days. Make sure that you follow along with Friday's video, because Friday we have this cyclogenesis case on Friday, and the timing seems to be perfect with the evening hours, which might make a good opportunity for me to create a video while the rapid cyclogenesis case is ongoing, and we can use our three-dimensional visualizations to show you how cyclogenesis come about and which factors come into play to drive the cyclogenesis forward, leading to a very rapidly deepening of the cyclone itself. So it might be a good opportunity to say also, feel free to drop a comment in the comment section if you like what I did so far. If you have some topic that you would like to see explained, do not hesitate to ask. I will definitely create a video on it if the topic is interesting enough and if time permits. And just subscribe to the channel if you want to be notified of any new content. With this, I will leave you. See you all in the next video. I might give one on Thursday, just before the cyclogenesis process starts, and the big one on Friday, which will be a blend of a deep dive potentially and a forecast, and see what's actually ongoing while the cyclogenesis process is unfolding itself.